All right, welcome. We are going to go over section 4.6, which is doing composite trig functions and then the graphs that go with them. So just a reminder, composite means we're putting things together. We can put things together with adding, subtracting, multiplying, dividing, plugging things into other ones. So we'll kind of focus on that. So in our composition, we're going to have kind of two types here that we're going to work with and focus on. The first type is we're going to blend trig functions with more trig functions. Okay, so that's not subtraction, just we're combining trig with trig. The second type that we're going to have is that we're going to combine some things that have trig in them with things that are non-trig. So maybe there's an exponential, maybe it's a quadratic, something to that effect. So those are the two types that we're going to focus on. Most of today will be calculator based. Some will be the no calc, and so I'll kind of make sure I highlight that. So as you continue, make sure you have a calculator handy because you're going to be doing a lot of graphing today. Okay. All right. So the first thing that we're going to be doing with these is sketch and analyze them. Okay. So that's kind of one of the first tasks that we're going to do. So when we say analyze, just a reminder that some things that we're going to be looking for, and we'll be very direct with this, we're going to be looking for, what is your period? We're going to be looking for what's your domain. And we're going to do an example over here. So we're going to be looking for, is this a function or not? So does it pass that vertical line test? Some things like that. Okay. So I'm going to make up kind of a graph here just to highlight and kind of go through what we're talking here. So something that might show up here. Oops, hang on, I want to redraw part of that. So let's go. There we go. There's going to be some symmetry, but these are not going to be perfectly symmetric like we've had in the past. And so there's going to be some, higher amplitudes, lower, and so we're not really going to have an exact amplitude because these will vary in how high things are. What you will have is repetition. So that's where the periodic comes from. And so some ways to find, the period, yes, we can do some zeros, but that gets really tricky if things are shifted up or down, or if you've got multiple repetitions or hills and valleys in your one period. And so what I like to do is look for something that goes from like a max to a max and say, okay, how far apart, are these two things from each other? Okay, so period we can find, but so what it's looking for in general is how long is one, and I'm going to say cycle. I know if you had me for, if you had me in class, I said wave when we were doing just sine, cosine. I'm going to say cycle now because it sometimes goes up and down a few times. And so one way with your calculator to help you do that is to look for a max and then see how long it is to get to the next max with those x values. So find the x value here, find the x value here, subtract them, and then see that gives you how far apart or how long your period is. Okay. So with this then, domain, is there any breaks? Does it not keep going? And you're going to graph this, you're going to get this off your calculator. This keeps going back and forth. So a lot of domains are going to be negative infinity to infinity. And then function, just a reminder, I mentioned it, but you're kind of looking for that vertical line test. Line test. And so this one is all, the waves don't overlap each other to fail your vertical line test. So they are all there. Okay. All right, so going on then, again, that's just going to be typing in your calculator. Oh, I should say this. With your calculators, you need to be in radians. So we need these things going through one, cycle, or if it was a normal trig period in 2 pi, if you have them in degrees, these are going to look very long, and it's going to take forever for one cycle, because it could be, if it was 2 pi, it'd take 360 before you went through one of these, if that was your period. So just right now, set your calculator radians. You're going to be able to stay in that for most. I can't think of a time when we switch it. It's possible later we'll switch to a degree here and there, but most of what we're going to be doing is in radians. Okay, so let's combine some trig with trig and see what we get. Okay, this part here is going to be the only part that we talk about today that will be done without a calculator. Everything else like that, the one I just made up, that was definitely calculator based. This is the only one that's not. Technology issues. Sorry about that. I know there was a couple seconds there where it just kept recording and not doing anything. Sorry, so we're back now. So like I was saying, this is the no calc part that's going to be there, where I've got some trig going with trig for that. So how do we know if things are sinusoidal? So sinusoidal, you know, we've used the term a couple times. We've seen it in directions. All that means is that you have things that repeat. So it repeats over and over, whatever shape. So this thing is going to be sinusoidal if, so this is what you're looking for, if your period is the same for both, I'll say trig parts. Let's say trig in there. For both trig parts. Okay, so this is only, again, where we're combining trig with trig. So if there's a quadratic in there, it's not, this doesn't apply to that. So when I go up here, I got to look for my period. So just a reminder, sine and cosine, your period is found by doing 2 pi over b. So for this first component, for the sine part, I just have a 1 right here. So this thing's period is 2 pi. This one, there's a 2 there. So this cosine's period would be 2 pi over 2, which is pi. So with those being different, this example is not sinusoidal. Now another way to think about that is you're looking for, they need the same b value because b is what dictates your period. So with this one having a 1 and this one having a 2, this thing is not going to be sinusoidal. Okay. How do we know if things are periodic? Okay. This part is a calculator part because you're going to want to see a picture. So periodic is another way to think about it. Think of like a heartbeat. So there is a, we'll describe it as a pattern repeating. Okay. So some pictures that are and are not periodic. So let's say there's some kind of irregular heartbeat and there's just randomness happening. This would be something that is not periodic. So we don't have a repeating perfect example. You know, maybe something like this. And as long as, you know, to the best of my ability, making these the same, and on and on. So if these are all the same, you know, like these would all line up, those all line up, and the little small hills there, that would be something that is periodic as you go. And again, if we're looking for the, you know, the period, for example, one period, 1p here, would be from here to here, or you could find it from there to there. You could find it from here, you know, the min to a min, this little max to the little max. There needs to be some type of repetition, okay? I do just want to clarify, with this repeating, with your sinusoidal, you need to have that symmetry of a sine or a cosine where, you know, your hills and valleys all have kind of this central, they're all the same, they have the same amplitude, I would say. So periodic is just the repeating aspect. The sinusoidal part is it repeats with that same amplitude. And so it looks like a sine, it looks like a cosine is another way to kind of think of that part. Okay. All right, let's actually throw this in our calculator and show you what this one looks like. So back to this first example. So if I go to my calculator, there it is. I'm going to go to my y equals, and then I'm going to check my mode because I don't know. I am in radians, so I'm good. So y equals, and I'm going to do the sine of x. Make sure you close your parentheses, minus cosine of 2x. Close my parentheses. And I'm going to graph it. I'm going to put my window back just negative 10 to 10. So if I do zoom 6, that will put me back. Okay. So this is not sinusoidal, we said. And that again is, yes, it goes up and down, but you don't have like the symmetry, like this hill and the valleys are different. So they don't have that, like that amplitude setup. This is periodic because you've got 2 small to 1 large, 2 small, 1 large, 2 small, you know, that repetition is there. So just to show you, I've talked about finding the period, but just to show you how to do that on your calculator. So I'm going to do for max to max. It just is easiest for me, especially with the 2 minimums that are happening. So I'm going to find this first max right here. So I'm going to get my left key. I'm going to just type it in. So we'll go to like -6. Will jump me there. And then I want to find the max. So we'll say the -4, somewhere in between there. So the calculator is going to find me the maximum y value between these 2 dotted lines once I hit enter, because it says guess right now. Guess. So my first, you know, value, I'm going to go on my slide over here, would be -4.7, what was it? 4.71. 1. Okay. Now my next max, if I find this one over here, same process. So I'm going to go second trace number 4 again. And I know that max looks like it's between, we'll say 1 and 3 to be safe. So 1, enter, 3, enter. That will find me the max between those 2, and I can see it's in there. So I hit enter one more time. And it's at 1.57. So 1.57. So on my calculator here, just so if I want to find how far apart those are, I would do 4.71 plus 1.57 because 1 was negative. So this thing's period would be 6.28. That's how long it took to go from a max to a max if you're doing this in terms of like the length to 0 and then you went 1 more. So yes, you have a negative value, but when you're doing length, you should subtract those 2 and do an absolute value. So that is your, that would be your period. Okay, so it is periodic. It's not sinusoidal, just to clarify that. And this calculation would be with the calculator, obviously. So really the only part in here that was no calc is just this question right here, which on your homework, it's number 23 to 27, just to kind of help you out. Those should be the 3 questions that you do without a calculator. All right, so the other type of combination is trig with just algebra, other functions, basically. So I've got these 2 examples here. So let's go on our calculator, and we're going to put example 1 into it. So I'll go to my calculator here. I'm going to delete out what's there. And I want sine of 3x. Make sure you close it, plus 2x. If you don't close it, all of that 2x stuff is going into the sine as well. So you definitely need to close it. Okay. Graph this. So you can see I kind of have this like oscillating, wave idea, but now I'm kind of going up and at an angle. Okay, so I'm going to sketch that onto my paper. It's not going to be perfect, but these are definitely sketches. So we're going here, something like that. Okay. So what happens is this is, we're going to call this a damped oscillation. Okay. And what happens is it's going to look something like a bouncy ball. Whoops, that's supposed to be C. Bouncy ball. Okay. Now this bouncy ball is kind of going up into the side there, but still the same idea. what happens is we can find functions that we're going to say they're the bounds of your, we'll say graph, or your function, your line. We can find the bounds that create these. Okay. So how we do that is we're going to take our function and we are going to replace the trig part with +1 and -1. So these are ones, just to make sure. So you place the trig with a +1 and a -1 because it's going to bound it on the top and the bottom. So one of these will bound the top, one of these will bound the bottom. Usually the +1 bounds the top, but either way it doesn't matter. Okay. So to show you what I mean by that is if I take this, here's my trig component. So my new bounds, or my bounds, are going to be y equals, so I'm going to put a 1 there, and then I still have the 2x, and it's going to be -1 plus 2x. So this 2x part stays the same. There's a plus symbol, so we're still adding. It's just that whole trig part got replaced with a 1 and with a -1. Okay. So I'm going to go back to my calculator. I'm going to type these in so you can see what happens and where they end up falling. So if I go back to my y equals, so I want 1 plus 2x and -1 plus 2x. There we go, calculator. So you can see there's my top bound and it's hitting it right at that max. And my bottom one, if I typed it in right, there it comes. And so you can see you're bounding this oscillation back and forth on the top and on the bottom. Okay, so if I add these on here, I'm going to graph these ones accurately because I know like the first one has a y-intercept of 1 and my slope is 2. Now, I'll just kind of follow. And then here's my -1. Again, it's kind of estimated. Hard to draw my little thing here. But you've got this oscillation back and forth, this dampened oscillation that is bounded between those two curves, and it keeps going on and on forever with that. So let's try another one of these. So we're going to get our functions, and then we'll go graph all of it together. So to find my bounds, again, I'm going to replace the trig part with ±1. So here's my trig part. Now, one thing you need to be very, very careful of is there's an operation here that's not written, but it is implied with things being written right next to each other, which is multiplication. So when I write my first one, it's 3 to the -x times 1. It's y equals 3 to the -x times -1. All the time I get students that just type in -1. It's very, very different because this is then -3x to the negative x power, and this is just 3 to the -x. If you simplify, you don't have to simplify. You can leave times 1 times -1, but that times is very, very important. You cannot just put, like you can't do this, oh, I'm going to put a -1. That is incorrect because that is implied that it is a minus. That's why you need the times there, or put parentheses, either of those work. Okay, the other way you're going to know if you do something wrong is when you graph it. If it doesn't bound your curve, something was wrong. So something got wrong in there. Okay, so I'm going to go to my calculator in a moment here. We'll type in the equation and my dampened, and we'll show you how they all kind of line up. So y equals, I got to take everything out. So I had 3 -x power. Oops, I got it on my y equals. 3 -x power, get out of my power, and then I'm going to go times the cosine of 5x. Make sure I close it. Okay, and then my dampened were 3 to the -x and -3 to the -x. There we go. Hopefully that works. Okay. You might need to make some of your windows a little bigger. Obviously, we're like, what are all these vertical lines? It's starting to dampen. I am going to make my window a little bit bigger so you guys can see it for my Y. Oh, stop graphing. Sorry, I gotta let it graph first. And there's the other one. No, it looks like these are all on top. They're just getting very, very close to zero. They're not on top of each other. So you got the idea here. Basically, you're getting really, really big. Here's that bouncy ball. It's going down, 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 down. It's still just kind of bouncing back and forth there. Okay, so if I graph this, and again, these are very much sketches. Whoops, my axes here. So I don't need exact how high, how whatever. I do need that these start to go down, and then you've got your exponential above it, and there was the exponential below it. That we're going there. Okay. All right, last example, this is a very short section, which is nice, is getting something that is trig with trig and converting it to just one trig function, and that's in that kind of that format that we talked about with transformations. Now the approximate is here because it's not going to be exact. We're going to have to round some decimals and stuff, so they're not going to exactly line up, but they're going to be very, very close. Okay. So before I start doing this, let's just review the no-calc aspect of this, that I have trig combining with trig, and so I can see, is this thing sinusoidal, question mark, and I look at the periods of both need to be the same. Well, I've got a 2 and a 2 here, so my period for both is 2 pi over 2, so my period for both is pi. So again, I'm going to flip back to where we talked about that. So that's right here. How do we know if this thing is actually sinusoidal, so I can write it in the sine function? Is that if the periods are the same for both trig parts. And so that's what we just did. We said, okay, they both have 2's, so they both have that period of pi. So that means that this thing is sinusoidal. So I can put it into one sine function because it has like kind of, you know, that same amplitude, the same, you know, it just repeats after one wave, all of those properties that we had back in the last sections, really 4.4 when we were graphing. Okay. Now, to get all the other stuff, I should say that this means that B is 2. That is, you know, that's what both of them had, so your B value is 2. When I look here, though, I still need to find an A value and this H. So A is your amplitude. Let's just write that down. Amplitude. And that H thing is that phase shift. Oops, that's supposed to be P. Phase shift. Okay, those two aspects need to come from your calculator. So we're going to graph this whole original one. And then we can figure out from that picture what's my amplitude and what was your phase shift that happened. So I'm going to switch back to my calculator and then get that thing graphed. So clear out all this. Clear. Here we go. So I want to graph 2 sine of 2x. Oops, I did it again. Let's try that. 2 sine of 2x. I make sure I close it, and I'm going to subtract 3 cosine of 2x. Okay. Now, just to show you, I'm going to change my window to 2 pi, like negative 2 pi to 2 pi, so you can see that it is one, like one period is pi, so I'll have a couple of periods in this case. So when you're doing windows, you can type in like 2 pi, negative 2 pi in for your x's, so that you can see, in this case, it should be 4 waves. So there was one, there's another. All right, so this is your sinusoidal. I have a same amplitude going up and down. I have the repetition of just one wave. I don't have, you know, one higher or one lower. So this is that sinusoidal, what it should look like if it's sinusoidal. Okay. Now to get my amplitude, I need to see how high these things are. So I just need to pick one and then figure out, you know, how high am I? So that would be, you know, a max or a min. I'm going to do a max because it just gives me positive values. So number 4, and then I just pick one. So we'll find the one between, you know, 1 and 2 there. Whoops, I hit the wrong button again. So sorry, 4 max. So between 1 and 2. So it's going to find me that value. So when I do that, yes, I get an X, but I want the Y value in this case. That is going to be the how high that I go. So in this case, I want 3.61. Okay. So if I go back here just to kind of write what we did. So to find A, I want to find a max, and again, or a min, height, which is a Y value then. Okay, so in our case, it was 3.61. Okay. Now remember, your phase shift is shifting right and left. Right slash left. Okay. And so normally, so I have sine here. Normally sine starts at the origin. It goes through 0, 0. If I switch back to my calculator here, I am not going through my origin. And so what we need to do is shift, like basically take this function that was at 0 and I'm going to shift it. Now there are actually infinite amounts of answers you can pick, because you could shift, you know, the first 0, the second 0, the third, the fourth. You could go backwards. All of these zeros could be shifted back to the origin. I find it easiest, I always do the one to the right. You can always, you know, it's up to you. I just try to be consistent, so I do things the same. So I'm going to find where my first 0 is, and then I'm going to shift my function. In this case, I'll shift it right that amount, because it was supposed to start at the origin if we're using sine. So finding that 0, just as a reminder, go to second trace. Number 2 is 0. Again, you got to tell the calculator where to look. So I'm going to tell it to look between 0 and 1. So 0, enter, 1, enter. You can see the dotted line, so it's going to find the 0 between those. And it looks like your first 0 is at 0.49. Okay. So just again to kind of dictate what we're doing here. So right or left, I do this by finding the first 0 to the right. So in this case, that first 0 was at 0.49. And that is what is going to give you your H value. Because of this minus symbol, sorry, I'll slide up a little bit, that is a right transformation, which is the other reason I find the right one. And so this 0.49 is what goes in for H. So this thing as a sinusoidal would be A, which was, we got 3.61 sine. We said B was 2. Don't forget these parentheses, x minus 0.49. Close that, and that would be your function. Okay. You can check this. So if I go back to my calculator and I type that in, it should look close. It is not going to be exact because I've rounded the 2 decimals that were there. But just to show you that it is close, so I've got 3.61 sine 2. I get my second parentheses, x minus 0.49, and then close both. Let's check it, make sure I typed it in. Yes, I did. So if I go to graph that, you can see it's going roughly directly on that blue line. So I know I did it right, which is kind of nice. You can check your answers on these because they should line up exactly. Okay. So just to summarize, a lot of today is calculator-based. It's looking at, you know, periods and periodic and sinusoidal and kind of the difference between them. You're going to do a lot of graphing. Make sure you're in radians. And then this last one's kind of some application of all that stuff coming in of what's an amplitude, what's a phase shift, some of those transformations that we had back in 4.4. Okay, assignment should be on Canvas, but here it is as well. So start chipping away at that. We got 2 more sections for this set of tests, or this chapter, if you want to call it that. So tests will be coming up in a little over a week, probably.